So first thing to mention is that we have a default encoding, as we all know, which is a GML. But in discussions with the different member state stakeholders, in the discussions with the software providers, the open source, the proprietary as well, it became clear that the default encoding, even if it is quite handy for a lot of use cases, is not enough. We have, therefore, within the context of the Inspire maintenance and implementation work program, been investigating different encodings. A lot of work was done on GeoJSON, but especially in discussion with the software providers in one of the actions of the work program, where we had a study of client support, it became clear that the client support for GeoPackage is excellent. And also that there are many advantages of GeoPackage when compared to GML. So I think we have a clear case as an Inspire community to be investigating GeoPackage. To mention here, the idea here is not to substitute our default encoding, but to complement it. And what we're going to be discussing today, the webinar, is one of the necessary steps for the so-called good practices in Inspire. The good practices we have put in place together with the community in order to be able to innovate, to come up with new technical solutions within the limits of the current legal framework. So the way in which the good practices are scoped is the following. Each good practice starts with an initiation request, where those who are initiating have to actually provide the business case to explain which component in Inspire is being impacted, and also something very important, to provide evidence that shows how the proposed good practice is implemented in practical terms, and to also make sure that the good practice is reusable. So to make sure that the technical provisions can be replicated by other member states and in different contexts. All of this has already been done by the colleagues organizing the workshop. Many thanks for that. All the evidence is on GitHub. We will be seeing some of those examples in a bit. So what happens with this good practice process is, after the initiation request, after all the evidence is made available, there is this webinar for the visibility. And then the next step is formalizing the good practice. There is a voting procedure with the governance body of Inspire, the Inspire maintenance and implementation group. And then the one final step, which is internal to the Commission, where colleagues from DG Environment check that the good practice is in line with the existing legal framework. So we are almost complete with the process with the GeoPackage. And we have, in the end of November, the MIG meeting, where the idea is to already propose this for endorsement. Once this hopefully happens, GeoPackage can formally be recognized as one of the encodings formats for Inspire data. And with that being said, I would like now to once again thank the organizers of all of that work, and in particular Daria, European Environment Agency, our colleagues from Finland, Jari, Denmark, Heidi, as well as Torsten with Transform. And thanks a lot for all the colleagues who will also be presenting implementation evidence. Last but not least, of course, thanks Stefania and Epsilon for the work done on GeoPackage. That said, over to the organizers, looking forward to a very interesting discussion and all the interesting presentations. Over to you, colleagues.
Thank you very much, Alex, for the introduction. Daya, do you want to also say a few words, or should we just start or continue with the program?
Maybe we could just start with presentations and program, and more questions can maybe be raised and answered later.
Absolutely. So let's start. Yeah, good afternoon, everybody. Very happy to have this opportunity to present the work around the Inspire good practice for GeoPackages today. I will first, well, of course, obviously, I'll talk a lot about packages today. So first, we'll look a bit into the generic rules as to GeoPackage as an Inspire encoding. That's also what's described in this initiation fiche that Alex just mentioned. And then we'll look into one implementation example, looking into how GeoPackage has enabled END reporting and Inspire compliance, where also Jens Gonzek is going to then describe a bit about how exactly they implemented it and what their learnings from that process were. All right, yeah, let's get started. You already know quite a bit of that, I guess, or most of you do. GeoPackage is an open format, it's standards-based, it's platform independent. It has quite a lot of examples, and so it's a natural choice to make geodata more accessible to a wide range of applications, but especially in the GIS world. It's based on SQLite, which has also been used for quite a long time, and it's basically a convention on how to use SQLite, how to store certain types of things like vector features or tile matrix sets or tile gridded coverages, and so on, and also metadata and schema constraints. We've been using it for quite a while for data sharing between different GIS systems like ArcGIS, QGIS, various database systems, and so on. And it's really quite well suited for that because it's in the end a relational format and can thus match the usual structures that you have in these systems quite well. It is suitable for desktops. It can be used for certain server contexts, and it's often also used for mobile applications. So it also has this kind of portability. Can store quite large data sets if necessary, though, of course, there's some performance penalties if you really go into the many terabytes range for sure. And thus it can really replace quite a large set of especially proprietary binary formats that we've been carrying around. So it's kind of a natural choice to say, okay, there is this open standard. We want to have an efficient form of transferring Inspire data. And so this was a candidate for several years to also use to be able to transfer Inspire data. It would be said generally that one encoding doesn't always solve all problems. That's always true. Yeah, there are different formats for different purposes. I have been presenting similar things like the slides for a while, and I think most of you have seen this as well. So just generally, I think the statement is important is that it wouldn't really make sense to just say everything's GeoPackage or everything's GeoJSON. Now it's really about making the right combination so that on the one hand, it's easier to be compliant, but on the other hand, the data is also really useful in the particular application areas where it is to be used. As an example, GeoJSON is really nice for web and mobile applications when you deliver small sets of features to the client, but it's not so nice if you have really large data sets. For those, you would rather use GeoPackage. And these differences are also in some cases quantifiable. For example, there are things that you can do with GeoPackage, like reading with a filter that works extremely quickly because it has indices like a database format typically has. Whereas if you just parse a GML or a GeoJSON, you typically have to read the whole thing. It will be very slow. Yeah, so that's really very, very briefly on the format itself. So it's an open standard. It's been implemented in pretty much all relevant software. At least the core of it, extensions, is a bit patchy. It's well suited to this kind of scenario where I deliver a whole data set to a GIS user, which is, to be honest, a large part. Yeah, there's other things like delivering data via APIs. That's still what GML and GeoJSON are good for. But for this kind of expert use case, GeoPackage is definitely a very, very useful format. Yeah, so Alex mentioned this a little bit already. One thing that we really always have to be mindful of is that when we discuss different terms, like different places, what we will use GeoPackage for, there is kind of the default encoding, which is described in the existing technical guidance and for which there is central tooling, like especially the validator and other things available. Now, if we look at providing additional file formats, additional encodings, there's two ways that we can look at them. One is we really look at it as an additional way to provide our data. So we have GML plus, for example, GeoJSON and GeoPackage. Then I basically don't really need to prove that these data sets are compliant with the Inspire IR because I do have the GML data set for that. However, if I do create the data only in my alternative encoding, then I will really need to show, okay, this data set is compliant with the requirements that the Inspire implementing rules posit. And at the same time, no central tooling is available. So that means that there is a kind of a gap here. And yeah, one of the things that we needed to address in our work on GeoPackage is how to exactly do that. And I'll describe that in a moment. In the end, one thing this has to be really clear. The big challenge really is the schema into which we actually want, or which we actually want to use on a different format. In here, what we typically have is a relatively complex tree-like or graph-like structure that matches quite well to the conceptual model, which is a UML class-based model with inheritance, with all kinds of associations and so on. And this kind of structure, like I said, matches very well to something like GML or XML in general. It can also be matched to relational systems. And in fact, object relational mapping is kind of a staple of systems since, I don't know, 25, 30 years probably. So it's not kind of a new problem. But what we are now looking at is really the goal to not just do any kind of object relational mapping, but what we're doing is we're introducing GeoPackage because we really want to make the data sets more useful. And then just applying some automated mapping strategies in many cases isn't good enough. Just a small example, we are currently working on a GeoPackage schema for a German standard. And the first version that was automatically generated had 4,400 tables. So it's really messy, so to speak. Yeah, and just putting everything into database tables would not be the solution. That means that in our work on creating and supporting something like GeoPackage, we actually have to spend quite a lot of time in thinking how the conceptual model that we have, and that is more or less describing in detail what our implementing rule requirements are, can be implemented in such a way that we get a good, useful, and still compliant model for the structures that are expected here. And typically, what's done here is that you go through two steps. Here on the example of the European Noise Directive, the first step is that you build a domain-specific conceptual model that matches the use case that you plan to support, or the use cases in some cases. And then in a second step, you actually go towards the logical model. So there might be some simplifications already happening in the first case and some in the second step, sorry, not case. Yeah, and when that's done, let's have a look at each of these steps in greater detail. So first of all, it's really important that when you create a GeoPackage schema for a certain use case, you can look whether there are some already. Like, for example, we've now created one for END, and we will today see examples for, I think, addresses and for geology and a few more. But what this implementing rule doesn't come with is a full set of standard schemas for every Inspire theme. So instead, there will be basically a lot of different schemas that can then be used, and that can either be specific to a particular use case, or that can be relatively generic. And we'll see both. So we'll have some schemas today for GeoPackage that are more or less generic, that cover the theme pretty much in its entirety. But then there are also some that are more general, more specific, sorry, that are more specific and that really focus on a certain use case. However, in all of these cases, what you do have to do is you have to follow some basic rules that all GeoPackages should comply to. For that, we are referencing the UML to GeoPackage rule on how to handle geometries and things like that, that the University of Zaragoza wrote a couple of years ago by now. Also, we would really like to point out that it's important if you can reuse good practices. There are some that have overlap, and you should do so. Don't always try to invent everything from scratch. Because in the end, what we really aim for is to have interoperability. So we've discussed this a lot in the working group on GeoPackage. How far do we balance the needs to have interoperable data and the effort that we put on the data providers? And the goal here is, however, that whatever you do, there still has to be interoperability on a semantic level for sure, and on a syntactic one as far as possible. That brings me to the requirement 2. So when a new schema is created for example, GeoPackage, one thing that definitely has to be done is that whenever there is overlap between the types that you're modeling and that already exist in Inspire, you should really use the relevant feature concepts and feature types from the specific themes that match. You can use, for example, the Find Your Scope tool or the feature concept dictionary to identify those. Then on a conceptual level, you can basically say, or on a semantic level, you can say, okay, I'll extend these or I'll add things to those. But at the core, we really want to retain that semantic interoperability. To me, that's still the core value of Inspire, that we have these specifications and we should really build around them. Same is true for code lists. There are standard code lists. Yes, in many cases, they don't match that well to your national or specific data sets. But still, you should always make the effort to use these, to map to these, try to retain your original values, extend the standard code lists where possible so that it's clear what kind of relationships certain values are in with, but do use those wherever possible. Yeah, requirement number 3 is more or less that you also do structural reuse. So you don't just use the concepts as they exist, but you also principally retain their associations and also their mandatory attributes. That's also an important aspect. So don't throw everything away. Don't redefine the objects fully. But really look at the things that you want to retain. Simplify where you can, like, for example, with respect to cardinality or substituting them with simpler types. But do keep them intact as far as possible so that you can actually still see, okay, my specific model still matches back to the requirements of the implementing rule. You can always extend. So adding things is, of course, the easier part, so to speak, than deciding what you can remove. But for that particular part, for how to extend an Inspire model, there's still that resource that we created a few years ago with GeoNovum, Inspire extensions, website, you could say. I think that still applies here as well. Yeah, now that you've done the, you've applied the basic encoding concepts and you've had the semantic and structural reuse sorted out, the last step after creating your model is basically to prove that it's actually compliant. The data set that is expressed in that model is actually going to be compliant with the implementing rules. And as described on the GitHub website for the GeoPackage rules, the idea here is that you prove interoperability and IR compliance by delivering an executable set of transformation rules. These can have completely different forms. Yeah, you can deliver a transformation service, for example. That's something that Inspire has foreseen since the beginning. You can, in principle, also say, okay, here's this transformation project for Hail Studio, for FME, or for some other software. So basically, what you do is there you really show, okay, this data can indeed be transformed to the default encoding, and that data set can then be shown to be compliant. This only needs to be done once. Yeah, so only the team that develops the schema for GeoPackage actually has to do this once, and then everybody who wants to use that can stay pointing to the same transformation project that has already been defined. If you feel you're unable to do that, then the alternative would be that you just provide the GML in addition to GeoPackage or other encodings. But generally, this would be the idea. What you shouldn't be doing is just point to a matching table. We've worked for years with those, and the point is simply being that they are not sufficient to prove compliance. They tend to be incomplete and contain quite a lot of errors. So overall correctness was around 30 to 40% of these, so not awesome. So I would really have to recommend going with the executable approach. Yeah, there's also a bunch of recommendations that we would like to give. So one thing is, for example, that the question is, okay, how do we actually document the compliance? One thing is that you could add an entry to the metadata on domain consistency, where you currently state to which Inspire theme, for example, your data set complies. And you could add a specific good practice, so to speak, to add to that. We would also recommend actually adding a link to the executable transformation rule or to the transformation network service to the metadata. That's something that would still have to be developed, how exactly it's done. So we've done it in some cases, but I don't think there is a proposal for that yet. That would still have to be developed. Yeah, and for example, if you point to a transformation network service, then it would be very nice, of course, because people could just use that service to feed in a data set and see, okay, yeah, it does indeed come out and it's compliant. Yeah, so those are the core things about how to ensure compliance. In addition to that, you saw before when I had the example for the European Noise Directive, the conceptual to logical schema path, that I said, okay, there's actually a set of model transformations applied at each step. And while generally you can come up with your own, it will be very helpful if you also reuse the common model transformation rules, for example, the ones that are listed here. So when you're going from the Inspire model, both to your, let's say, domain-specific conceptual model down to the level of the logical model, you can apply rules like these. Many of them are, for example, implemented in the shape change tool, but there's also other tooling that you can use to automate that if you desire to. And do document that. So if you create the documentation and make it clear how you came from one model, from the original Inspire model to the one that you're proposing, you will be able to also automatically create the transformation rules in many cases, the ones with which you actually transform the data. All right, so that's a very, very brief summary. I would like to point out that there is the actual initiation fee that Alex also mentioned. It describes a little bit more about what I've just mentioned. For example, it also details a little bit more about what the benefits are to users and data providers. It also describes, again, the process and some examples that we had when the initiation fee was provided. So it should be a good base for you to read a bit more about what's been going on here. Now coming a little bit into detail for the END reporting. As you know, the European Environmental Agency for the 2020 to 22 reporting decided to do two things. First thing was they wanted to generally modernize the whole reporting process, which meant also improving how the data is ingested and how it's validated and so on. But they also wanted to make it so that all data sets that would be provided for END reporting would also be Inspire compliant. So the objective was to really enable delivery of noise directive data using various encodings, in particular Inspire compatible GML compared to shapefiles and Excel, what was done before, but also GeoPackage. And of course, the idea was that for both encodings, the Inspire implementing rules should be fulfilled so that there is no double work anymore for the agencies that have to provide these data sets. The first step was to create the conceptual model along the lines of what I described, and then to create fitting GeoPackage templates, samples, transformation projects, and other resources, and make sure they actually properly work in the software which is relevant. Yeah, as mentioned before, what we did in this case, and we in this case means mostly the EA team and Epsilon Italia, was that they took the relevant types from the Inspire specifications like area management, restriction and regulation zones, or human health and safety, or some transport networks, identified these schemas, looked at how well they match the requirements for END reporting. In some cases, added a number of properties, like here, for example, you can see there are things like the number of inhabitants, etc. So there's a bunch of things added to this type. And they also said, okay, there are some things which we're going to simplify, streamline, or constrain. So some properties, for example, are removed by simpler properties, or actually, when they're optional, they're actually removed. So you see the list of voidables, for example, is shorter. All right, and then the final step was more or less to take this conceptual model, that's the work that I mostly did, and transform it into a specific model that really matches GeoPackage. So tables with a simple structure, and that's pretty much it. And so this process was applied for a total of 10 schemas. So there's 10 data flows, and for basically each one of these, a schema was developed for noise sources, noise exposure, quiet areas, and noise action plans in particular. And these have then basically each one been and developed and provided. There's a couple of things that I wanted to introduce that we applied here. One thing is you probably know that when you have a complex schema and you try to make it more compact, one of the things that can happen is that you get a very long list of properties. What we wanted to do is to really keep our tables and types lean. So basically a lot of things were simplified, flattened, or actually when the property was always the same, it would be relegated to a table called dataset default properties. So that in the end, for a relatively medium-sized schema in Inspire, we actually came up with a set of tables like this. Yeah, the END GeoPackages were created with all kinds of tools from what we've seen. Initially, the templates were created using Hail Studio, but by now I've seen people really using all the tools you can imagine to create them. Most of the time they are also compliant, but that's something that I guess Jan will also briefly report to. So generally people have been able to create these GeoPackages with pretty much every tool that supports that. And they've been delivering them. So for a few months now, the reporting has been open and people have been delivering the deliver GeoPackages to AONet, to ReportNet, sorry. And both for sources, for example, and some of these are already fully correct. Like this here is, for example, an agglomeration source data set from Malta. But I've also submitted some data already for other areas. Here we have a few from airport sources, in this case, Spain. Yeah, and so generally speaking, before I hand over to the specific experience that Jan has, I just want to say that at this point, there's literally hundreds of organizations who've used these templates, and I think it's pretty robust. And from what we can see, the adoption there has worked really well. And I think I'm not aware that many people have actually chosen the GML option, simply because from the feedback that we got, there are some smaller traps in GeoPackage, but largely speaking, everybody has been able to get to the target. And with that, I'd like to hand over to Jan for a more specific experience report on how this GeoPackage-based process has worked out in the Netherlands.
Thank you, Thorsten. I will try to share my screen. Can you see my screen?
Yes, looking good.
Okay. So my presentation is probably a little bit too long, so I will go through it quickly. So Thorsten just explained more the technical parts about the geocoding and the relation to Inspire. I will have a more use case from how we actually use it in the Netherlands to and take care of that all these municipalities and regional authorities can deliver the environmental noise directive data. So what was in the past was actually a problem was that there are actually two directives which are related to noise. One is the Environmental Noise Directive and the other one is Inspire. And in the past, these were actually two different data flows. So the really nice thing is that when making the EEA, the new data model, is actually that they tried to make some more conformity between these two data models and data flows for the END and Inspire. And therefore also avoid multiple provision of different spatial data sets, more harmonization, and there was also some update of the ReportNet platform, so also that would be better. And actually that resulted in a data model, nicely documented in a document of 217 pages, in which you actually have one data model in which both requirements for the END and Inspire came back into the data model, which was a very positive thing, I think. Besides that, the EEA also provided a lot of support. So Thorsten just explained that all kinds of encoding was made for GML, but also for the GeoPackages. There was very good data model documentation. There were a lot of guidelines for each data flow, and there were also examples in the GeoPackage, but also in Excels to help the agencies and actually the competent authorities to deliver the right data. There was also good documentation on the validation rules, which means when we upload the data into ReportNet, that it was nicely explained what the validation rules would be. And there was also a nice instruction video. In this case, it was done with Hill Studio, so an open source tool in which actually was explained how can I transform a shape, and Excel actually also provided this in these templates to a regular GeoPackages, which complains to the END data model. So what does that mean for the different Dutch authorities? Actually the data providers for all these noise maps. For them, Inspire actually is something probably not known to this user group. Actually, these are noise specialists. Every 5 years, they have to provide these noise maps. For them, it's once in the 5 years. It's not a routine, and a lot of times there has been some staff changes, so a lot of people don't know anymore how they did it last time. According to that, there were also some new calculation prediction models, which they had to change. And then there was this new END data model existing of 217 pages. And there was a deadline. So for a lot of these Dutch authorities, it was quite some work to provide all these data. Who are these data providers? Actually, these are the competent authority. So these are not national authorities. That are only 3 national authorities, but mainly these are local authorities who actually have to calculate and make these maps, and in the end have to provide those. So the users are actually noise specialists. They are used to use specific noise calculating software and mapping software. They're used to shapes, not to GeoPackages or GML. They're normally no data or GIS specialists, and probably no of them has any Inspire knowledge. So what we did in the Netherlands, there was an existing national noise data platform, and we tried to use that platform and extend to make it possible to deliver and also provide finally the END data to Europe. And in this case, all these local and regional authorities, they deliver the data to a central platform, to this national platform. And this platform finally then takes care of the transformation and aggregation to the national data sets. And these national data sets, they should be provided to ReportNet, so according to the END, but also this national data platform takes care of the Inspire services, including download GeoPackages. What was the approach? We had a quite tight timeline, and we have asked all competent authorities actually to deliver this END data, not in shapes, not in Excels, but we decided to use exactly the END data model, and we also decided that they should use the GeoPackage encoding. They should upload that to the central platform, and we will do as much as possible of the validations in our platform, but also because we had a tight timeline, also we did some additional quality and manual controls. In the back end, we used actually a cloud solution. In this case, it was Help Connect. And there actually we made all the validation rules, we did aggregations, and we did also the transformations to Inspire, and they will also provide these Inspire services. So actually on all the technical part, I'm not a specialist in Inspire. Actually, all this part is actually done for us in the background. So personally, actually, I never had a detailed look into all these technical encoding details. For me, the basis for us was the END data model, and that we were validated on as a base for the rest of the process. We provided some test environment for all our competent authorities so they could test, and we tried to support our data providers as much as possible. In that way, we actually reused most of the material which was provided by the EEA. What we did was actually we used almost the same guidelines, but we made some translation, or we adjusted a little bit to the Dutch situation. The same actually for the templates, we just reused them, we made some very small changes, and we provided that actually to all our data providers, competent authorities, so they could use that all in GeoPackages, and we provided the service desk. Experiences. What we noticed of all these data providers in this specific noise field, actually mostly none of them, of these users, had any experiences with GeoPackages. So normally they were used with specific noise software and were familiar with shapefiles and etc. However, we found that the learning curve was quite fast, and we saw that they had no experience with GeoPackages. So actually they were looking, and they finally found their GIS colleagues in their organizations. And after they found them, actually the learning curve was quite fast, and there were sometimes some difference between Esri software and QGIS software. So sometimes there were some little interpretation differences, but generally actually it went quite well. They could use the standard GIS software. They had not to make any specific software. And there were also a lot of consultancy companies who did the work for the competent authorities, and they actually started supporting GPS also as an export format. We found out that the templates and examples and instruction videos were very helpful. So they used these instruction videos, and they really followed step for step these instruction videos to generate the right GeoPackages. Sometimes we had some comments that the validation errors we provided and the messages were not always that clear, and probably we should have made more automated validations rules in our platform, but due to short and tight timelines, that was not always possible. The experiences from us, so from our national data platform, well, probably the implementing the validation rules, they probably take more effort than using a GML application scheme. So in this noise platform, you also use a GML application scheme for another noise data. So probably it takes more time to do it exactly right when you use GeoPackages. Sometimes it can be easy, even if you have especially when you have a short time, that you sometimes miss certain validation rules, or you didn't even think about people that's not logical for this data provider to do it that way. We had to balance also because of time, what would we automate in our platform and what is manual. Also because actually these data providers only have to provide this data every 5 years. We noticed that quick and good support to the authorities is very helpful, not only for them, but also for us. We get a lot of feedback and can act quickly and maybe add validation rules or correct errors we made on our side. And in the back end of our platform, we use the public cloud solutions. And the main reasons were we had our own development team, but actually they had other priorities and deadlines. So actually we had no capacity to pick this up in a short time. There was also some limited knowledge in our project team about Inspire. And in this way, actually, we used, let's say, standard software for transformation and Inspire services, and also benefited from the knowledge and experiences that was related to the Hail Connect studio. And these were finally the results. Actually, we're not ready yet. We have to deliver at the end of the year, but we did some almost successful deliveries to ReportNet for the different data flows. And well, we use Hail Connect for the Inspire services. And actually, everything is done then on the back end. So there are the transformations. They transform it from the GeoPackages to the GML and to the Inspire services. So actually, this is it. Yes, so I'll try to do it very quickly. So there's some time for any questions.
Yeah, thank you very much, Jan. I think there's a large block for discussion and questions at the end. Not sure.
Okay.
Alex, should we have an immediate discussion on something, or should we just proceed? I guess then we'll proceed. Yeah, Stefania would actually be next then.
Thank you,
So,
Thorsten.
yeah, thanks again.
Trying to share my screen. Is it okay? Okay.
Yes, looking good.
Okay, thank you. So, with my colleagues from ISPRA, Chiara D'Ambrogio and Maria Pia Conci, we will share today our experiences with implementation of Inspire Geology data theme. Our experience was originated in the context of the GeoPackage EU project, where we are reusing in a specific GeoDepth use case an Inspire extended geology data model to deliver easy to use and interoperable subsurface data. What we will see today, our experience with geological map of Italy, 100,000 scale. And there we are comparing our experience with GML encoding and GeoPackage encoding for the same data. Sharing lessons learned dealing with GeoPackage geometry, clearly referring data theme geology. And our experience in sharing GeoPackage data via OGC API feature. And then, and presentation will be from my colleague Chiara, we will see how we transformed and deliver plane subsurface data using Inspire Geology extended model and GeoPackage encoding. So starting from the very beginning, 277 geological sheets at scale of 100,000 that have been transformed according to Inspire data specifications. And harmonized data can be downloaded in GML format from the Inspire GeoPortal. And they are shared via Atom service. And indeed, all data that is needed for the geological map was split into 3 GML files, one for data related to northern Italy, another one for southern Italy, and one for the center. because mostly of usability issues. So long loading times in GIS desktop, 3 to 4 minutes per dataset. So when we tried to use the overall GML, took around 10 minutes or even more, and above all, issues were related to querying specific features in the layer. And the well-known issue with GML, so there is no possibility to edit, save, and in practice to categorize in GIS desktop. Yes, we can create joins, but then between the different layers, but it is difficult and quite long asking information about the specific features, so to query the layer. Decision then was to try to see whether it would be better to handle this data using a GeoPackage encoding, but without losing interoperability. So making full reference to the INSPIRE geology data model UML. So fully reusing the conceptual model from INSPIRE. So we created a GeoPackage logical model following the GeoPackage encoding of INSPIRE dataset specifications. And we created a GeoPackage template. In the interest of time here, I'm not going into the very details here, but we created this GeoPackage template and used this GeoPackage template as output to produce INSPIRE GML, INSPIRE GeoPackage. What we did was to create a Hail Studio transformation project where in input we have the INSPIRE schema and INSPIRE data that we are sharing in the INSPIRE GeoPortal, so the 3 GMLs shared in the INSPIRE GeoPortal. As the output, we use the GeoPackage template, and we perform this alignment. Indeed, this transformation is quite straightforward, so no specific issues. Only tricky bit is related to creation of composition part, so the lithology associated to the unit, because there in INSPIRE, the data type is embedded in the geologic unit, and now we have to create an external table and clearly create a relation between the table then. The output of this process was one GeoPackage file. And you can see here that the size of the GeoPackage file containing data for all Italy is more or less comparable to that of one single GML. But I wanted to share pros and cons, but indeed we have experienced only pros there. We have a single data set, but it's not so much in the size that we found major benefits, but in the fact that it took only few seconds, let's say around 10, 12 seconds, loading times in GIS desktop. We have the possibility to edit and save also portion of the data, preserving the GeoPackage structure, and possibility to categorize and include the style directly in the GeoPackage file, and possibility to provide views and relation. Following what is required by the GeoPackage encoding guidelines that Thorsten was mentioning before, we wanted to test possibility to derive back the INSPIRE GML dataset from the GeoPackage dataset and assess that there was no information lost. So what we did, we created another Hail project in which the input was the GeoPackage just created, and the output was INSPIRE schema, so the INSPIRE GML. The alignment is quite straightforward. It's, let's say, one-to-one mapping. And we derived our GML dataset, and we wanted to test whether there was information loss. So we overlaid the layers in GIS environment, and they perfectly overlaid. Then we wanted to see whether this GML that we derived was compliant with Inspire. So we asked the Inspire validator, and it seems that it was quite happy with what we had produced. Coming back to the experience, so one of the pros we experienced using the GeoPackage is the possibility to categorize data. So in particular, it is important to reference in the case of the geology data also the lithology, because geologic units are mostly specific from country to country, while lithology concepts are more widely shared. And so we decided to add to the geological map GeoPackage a lithology view, and we categorized this view according to the portrayal scheme developed for One Geology Europe, which is recommended in the Inspire data specification as a style for WMS layers. And we created this GeoPackage with geological map of Italy. That we have shared also in the Inspire MIF repository for the GeoPackage. Good practice. Lessons learned while creating this GeoPackage. So mostly we want to share our experience with geometries. So in the Inspire geology model, the geometries for all the feature types is provided by the mapped feature. And this geometry, so it's the shape attribute, is GM object. So general can be polygon, points, or whatever geometry. So we found out that there is higher chance for support by different GIS applications if we define tables using specific geometry types, so not the general geometry types. The geometry type is supported by the GeoPackage encoding specification, but for example, you cannot drag and drop, in that case, directly your GeoPackage in QGIS environment, for example, because the geometry is not recognizable. You have to add the layer as a vector layer. You cannot even use the database manager in QGIS because there you are asked to select a specific geometry for all the mapped feature. So what we also experienced is that we have better performances and easier mapping when specific tables, for example, the geologic unit tables, the fold, and so on, include their own geometry columns. So after a first exercise in which we had used a table for the mapped feature containing the geometry attribute, so the shape, and providing geometries for all the feature types, we decided to go for an embedded and specific time geometry. So we decided to provide the geometry in the specific table, so in the geologic unit, in the fold, in the natural geomorphologic features, and so on. And also we decided to split, so to duplicate table based on the specific geometry. So in the case of natural geomorphologic features, we had the polygons for the landslides and in this case, and the points for the caves. So we decided to make these changes for the specific use case of the geology data team and ISPRA data. So having this in mind, once we modified the GeoPackage template according to what I have just said about the geometry, we created this GeoPackage containing not only the geologic unit, but also the faults, the caves, the faults and landslides, and so on. So the full geological map of Italy. And the overall size of this full GeoPackage is around 500 megabytes. So quite manageable, and that would be quite more heavier to create in GML, and above all we would have had the need to create several GMLs to have all this. And so last slide from my side. How we are sharing this GeoPackage data via OGC API features. There are we are still testing, and tests indeed we have already performed on the data harmonized according to extended geology model, so in the GoPag context. And there we experienced that we used GeoServer as web server, and we experienced that creating GeoPackage data store, we are able to provide the entire GeoPackage dataset. Clearly, we can. There is the automatic mapping to, for example, GeoJSON. So if you in the request provide as format the GeoJSON, they will the APIs will provide you with the GeoJSON GeoJSON encoding. But it is possible to ask for the entire GeoPackage dataset. But it is possible to query data and obtain GeoPackage subset responses where structure is preserved. So if you click, for example, here, you will get a GeoPackage having the same structure, so according to the GeoPackage template we mentioned it before, but containing only filtered data. And we also experienced that it is possible to connect QGIS directly to this API service and download data in QGIS environment. And with this, I will stop sharing and leave floor to my colleague Chiara from ISPRA that will talk about experience with POP-lane subsurface data. Over to you.
Thank
Chiara.
you, Stefania. I share my screen. Okay, I hope you see. Okay, thank you very much. Please let me introduce myself. I am Chiara D'Ambrogi. I am the responsible for the Geological Field Survey, Biostratigraphy and Subsurface Modeling Unit at the Geological Survey of Italy. And I present you the results of the GoPag project for the geological subsurface data, where we have the role of stakeholder, looking for some solution in organizing, sharing, and delivery subsurface geological information that are derived from 3D geological models. 3D geological models includes objects such as surfaces and volumes that includes many different attributes, and with complex geometrical relation between the objects, such as those depicted in this slide. The geometries in the 3D geological subsurface model are mainly volumes and surfaces. The volume describes geologic unit, and the surfaces describe faults or boundaries between the geologic units. So the first step of our work was to simplify the volume, and we decided to express the geologic unit through surface representing the boundary of the geologic unit, and the geometry is a collection of points X, Y, Z, T, where T is the thickness of the geologic units, thus representing the volume of the unit. The second step, for the second step, we look at to find some solution to share this large amount of data, subsurface 3D geological data, in an easy to use, interoperable, INSPIRE compliant and editable form. First of all, we extended, as Stefania already said, the INSPIRE geology conceptual model, reusing GeoCML concepts where needed, and then we derived the XSD for this extended model. Unfortunately, the GML encoding resulted not suitable to handle this large amount of subsurface data. So we look for the GeoPackage, and we produce a GeoPackage template. And in this case, the GeoPackage encoding allow us to handle all the complex subsurface data we had, especially the volumes. We tested the GeoPackage encoding on the 3D geological model of the Po Basin that we realized in the European Horizon 2020 Hotline project. This 3D model extended over an area of more than 30,000 square kilometers and reached a depth of 12 kilometers. We extracted 4 geologic unit boundaries and 180 faults for about 500,000 points with attributes. The result is shown in the next few slides. The GeoPackage in the GIS included many different layers, and if we click on a point of the boundary info layer, we can access many information describing the contact type, the geologic unit, the composition part role, and so on, that are INSPIRE and GeoCML concepts. So click on a point and we retrieve information on the elements, the depth and the thickness for each of the point of the boundary. Does mean represent the unit of the thickness or the unit of the volume of the unit, of the geologic unit. And we can retrieve the information on the depth also using the isoline layer, where we have the depth represented as isobat. And if we come back to the points, we can access more information, as I told you before, the boundary. In this case, we reuse the contact type concept by GeoCML and the related code list, but we extended through the terms top and bottom in order to better identify the geologic unit above or below the boundary. Then we can move to geologic unit or the composition or the history, and in all these cases we refer to INSPIRE concept and the related code list as much as possible. Of course, we can access also information on the faults expressed as a shear displacement structure according to the INSPIRE data model. This layer includes lines for the faults. Clicking on a line is possible to access information on the fault type. Again, a link to the code list of INSPIRE, but we can also access information on geometrical value that are derived from the 3D geometry of the faults. And also in this case, we can access this information clicking on a point in the 3D fault layer, where we have all the information related to the shear displacement structure, but we have also the depth for each of the points included in a fault. Finally, I can say that the GeoPackage is for now, for us, the best solution for sharing and delivering subsurface geological information in interoperable form. Thank you very much.
Thanks to you, Chiara. And if there are no questions, we can leave the floor to Heidi, which is the next to present.
Let me just share my screen. Yes, you should be able to see it now, and I will be presenting together with my colleague Lars about our implementation of INSPIRE addresses in Denmark that we've been working on. So the first thing we would like to talk about is about the model-driven approach that we use. So as those of you that are familiar with INSPIRE know, we have, of course, UML models. We've seen some examples of that before. And from those models, we have earlier derived the INSPIRE GML application schemas. And we use the same approach in Denmark. So we have our national models in UML, and from that, we derive different kinds of artifacts that we then use in our data structures and the moving of data. So what we did with the national data is that we have the model and that we have derived a DDL, so basically the structure of the data in our Oracle database from that. What we then did was take the INSPIRE model and then use this tool called ShapeChange to derive from the INSPIRE UML model an INSPIRE GeoPackage template. We then also have in our database some views that basically take the data according to the national model and restructure that to tables and views and columns that basically fit more with the INSPIRE model. The automation of the INSPIRE GeoPackage templates is automatic from the INSPIRE model. The views in our database are created manually, but of course, that structure can be reused. It's basically a one-to-one mapping. It's just that the GeoPackage is based on SQLite, uses some different data types, etc. But basically, those match very well. So as I mentioned, we use this tool called ShapeChange to create a GeoPackage template. So basically what we do is we have the UML model and we then have a configuration file, and then we can run the tool and get the template from that. So in short, what is it we do? The first thing we actually do is an extension of the model, because in the Danish data, we have a geometry on both postal descriptor and address area name. That is not in the INSPIRE model, but we have that data and we would actually like to add it. It's very useful in a GIS context, of course. What we do is also to flatten the inheritance structures, the data types and the multiplicity in order to have a model that is more suited for relational database technology. And the last thing we do is, of course, to map the data types in UML to the data types that fit with the GeoPackage. Just a few more words on the flattening of the multiplicity. So one example of that is that an address can have one to many address components. Of course, in practice, the many is limited to a number. So what we did was actually look into the Inspire data specification and have a look at the examples that are in there that actually give a good overview of what we can expect in European data there. So the flattening of the multiplicity was based on not on the theory of the one-to-many relation, but looking, okay, what can we actually expect in practice and what does the template have to accommodate? In the UML model, there's a lot of definitions that define all the feature types, that define all the attributes. There's definitions, there are comments, etc. And for those of you that have read the data specifications, those definitions are also taken from the UML model. So when using shape change to create a GeoPackage template, then those definitions are also taken from the UML model and are then entered into this GeoPackage template. There's this table called GeoPackage contents, which is defined in the core part of the GeoPackage specification. There's also, that's then defined in the extension, the schema extension, the possibility to add all this information for all the columns of the tables that we have. So by using shape change to create a template, we actually have also the definitions in there. And when you have the definitions in the GeoPackage templates and then also in the GeoPackage with actual data, then it is possible to show those things in GIS applications, or you can also look at it in your own database tool. So this is basically part of when GeoPackage is described as a self-describing format. This is part of what that means. The second part is about the data flow and the mapping, and here my colleague Lars will take over.
Yeah, thank you, Heidi. Our data flow follows this architecture. We have our data source, which are the day-to-day management of our address data within our agency, and they are collected into our data warehouse, our Oracle database, according to our national Danish data model. And in there, we do the transformation to the Inspire data model by database views. And the next step is then to populate the GeoPackage template. In the past, up to now, we have been using GML files for the encoding of our Inspire data, but we are now moving towards GeoPackage. And the population of the GeoPackage is done by the ETL tools FME, and then we upload the data, the GeoPackage, we zip them and upload them to our FTP server, where there are atom feeds. So our Inspire data is available as predefined atom feeds. And this is our current setup for delivering our Inspire data, and we are moving to a second options, which are on the next slide. Yes, thank you. Where we will take our data, our data transformed in our Oracle data warehouse, our Oracle database, and then using GGL and transform the data into our PostgreSQL, and then again using GGL to populate the GeoPackage template. So this setup has no use of FME, but pure GGL. So we are moving towards this option for the data flow. Mm-hmm. Yes, and on the left side, you see an example of such a database views where we do the transformation from our national data structure to the Inspire data model. And as I said, we then use FME to do the population of the GeoPackage templates, and it's rather straightforward. No transformation or it's a pure population writing into the GeoPackage templates, and we then zip it and provide it to our FTP server. And therefore, therefrom you can download them, and as you will see in the next slides, it's quite easily to open here this in QGIS, and the attributes from an object, an address object is shown in this way. And this is according to the GeoPackage template as Heidi was shown. Mm-hmm.
Yes. So then the question is, how do we actually validate our GeoPackage files that we create? So the first thing that we do is that we take a direct validation of our GeoPackage. Actually, we start with the GeoPackage template because it is the smallest file. So there is this tool, it's called the OGC validator tool. It's also called the Team Engine, I think. So there it supports quite some test suites, and also for GeoPackage there is a test suite with actually the tests that have to be done described in an annex in the actual GeoPackage specification. So it's possible there to upload the GeoPackage template or a GeoPackage with data. It's just that ours is pretty big, so we did it only with the template there. And then you can see if the GeoPackage file actually complies with the GeoPackage specification. You can also get an indication of what extensions do you support. And then the second validation, that's an indirect validation.
Yeah, and this show how we go from the GeoPackage to the Inspire address GML file. This executable transformation process. Again, we use FME to do the process. So on the left side, we have all the GeoPackage tables from the GeoPackage file, and then we do the transformation in the green boxes, and the outcome is an Inspire GML file. No details here, but it's of course a quite complex exercise, and you go in very deep mode into your data, and it's quite a good exercise to validate your data, I would say. But nonetheless, at the right side, you can see that we will end up with an GML file, and of course we will have run it through the validator, and as you can see, it's entirely green, or almost. There is one red error, and we can live with that because it's about our coordinate reference system. We use EPSG code 25832, and it's not on the list in the annex for allowed coordinate reference system, but we have this adopted proposal that additional coordinate reference system is okay. Yeah, we consider our GML file as in green. Mm-hmm. And yeah, this FME workspace or project, we will it's general because it has the template structure of the template as an input, and then has the GML application schema for address as an output. So it's a generic workspace that can be reused.
Yes. There is one issue that we encountered that we would like to share with you, and that is on date times and time zone support. So if you read the GeoPackage specification very carefully, then it requires a specific format for date times. It requires that date times are expressed in UTC time, so not in Danish local time, not in a time with a time zone offset, a UTC offset, but it has to be in UTC time, and you have to have the Z in the end to indicate that it's actually a UTC time. There's a link there to an issue where I earlier asked for clarification regarding this, and it was indeed confirmed that that is in general the recommendation from OGC to store date times in UTC times for interoperability, and that was then also confirmed by the working group responsible for the GeoPackage specification. We have been testing some of our data, of course, in different GIS tools, and one that is widely used is QGIS. So we did a small test with some data where we both had it in the Danish local time with time zone offset added, and then with the UTC time. And we see that when we display that in QGIS, that it doesn't look at the time zone in the data, but it just shows the time zone of the operating system of our computer. So if I would change my computer to be somewhere else in the world, then it would show that and not what I actually have in data. So if you have any ideas on how to solve this, if you have any workarounds, perhaps, if you have any input, if you know developers, or if you know projects where support for QGIS could be added, then please get in touch with us, or maybe even better than write your whatever information you have on the GitHub issue, for instance. And with that, we've come to the end of our presentation. So thank you very much for your time.
Yeah, thank you very much as well. Since we're a bit behind time, I would propose to directly switch to the last presenter, to Jari. And then, yeah, if there's any questions, please put them in the chat, and then we can start looking at them in parallel there. Jari, we can see your screen. Please take it away. But we can't hear you at the moment.
Yes, I'm doing
Oh.
things. So can you see it now? I somehow lost WebEx window, but maybe that's okay.
Looking good now, Jari.
Okay, good. I will start my video as well. Okay, thank you. So I will have a last presentation this afternoon. I'm also talking about addresses in my presentation, so a little bit following or moving forward, or same structure what Denmark had. So we have Inspire addresses, and we have implemented a GeoPackage encoding for that, but we are using API in delivering GeoPackages, like it was in Stefania's presentation as well. And then I have a few words about styles in GeoPackage. It's a bit out of scope for this webinar, but it's maybe nice to know that styles can be used in GeoPackage, especially with QGIS. So if we start with UML model for Inspire, really not going deeply into the details in this one, but we have addresses and we have different information there available, and this has been mapped to GeoPackage as well as GeoJSON. And if we are looking at this from implementation viewpoint, that we have Inspire address data. So this is GML. And if you request from the current download services exposing WFS, and you will get GML as an output. So I here have an example of one address. So what you will actually get in GML, you will get the first GML or XML file with street number and designator, so the number of the street. And then you have 4 stored queries to actually ask a bit more. And if you follow through these different stored queries, you will get information like in this case, country, is one of the data you will get. The second stored query will get the municipality name and maybe some additional information, as you can see from the screen as well, and maybe in different languages, like we have two different local languages, Finnish and Swedish. And then you will get the postal code, and last you will get a street name. So you have several different stored queries to go through before you get the actual information available. However, what we made, we have now OGC API features up and running, and we made a mapping from UML and GML to GeoJSON. So here we have nicely in one page all the information what we had available through GML. So this is quite powerful and can be easily read directly via different desktop applications or other tools like QGIS. But the topic for today is obviously encoding as GeoPackage. So OGC API feature usually supports GeoJSON and HTML. However, there are no mandatory codings defined, so it can be anything. And Inspire Maintenance and Implementation Group MIG has already endorsed interface for OGC API features as a good practice. And now we are working on GeoJSON and GeoPackage in this webinar, mainly on GeoPackage. And we are relying on these links, what you can see below there in the bullet points. So how the mapping has been done. We haven't actually done any validation, and I have had a lot of discussion with our Nordic colleagues from Denmark. So we might give a try to use this FME workbench in the future also to validate our GeoPackage towards GML, as it's FME, and we have FME licenses as well. So if we are looking how you will actually get that data available, so we have OGC API features endpoint. It follows the OGC API structure, having collections and some addresses. So that address is collection and it has items. And then I can query in different ways. Like in this case, I'm using some bounding box to get content. And the keyword here is that the format is GeoPackage. By default, our OGC API features is delivering page information in paging. So now when I have a limit -1, it will get everything from the bounding box what I defined. But by default, it only gives you 10 or 15 address points. So like in my screenshot, I only got the limit amount of content to be visible. So -1 would give from the bounding box information available. You can switch different coordinate reference systems. So we have WGS84 and our national coordinate systems. And then we have also query parameters. So you can ask all the addresses, for instance, from Helsinki or any other municipality. And then you can have that as a GeoPackage output. So it has some kind of filtering, default filtering available, what is delivered through OGC API features core standard specification. Finally, when we have our GeoPackage, we can see the data. I could also show it on QGIS. This is a screenshot from a database viewer. So we have different street names, postal descriptors, country, Suomi, as in other words, Finland in English, etc., etc., and the structure of the GeoPackage. This is a screenshot from QGIS when you have clicked on one address point, and you will get all the information available there. And also in other tools, it's quite easy to use. So that's our GeoPackage implementation. So one can get data through OGC API features using either GeoJSON encoding, but can use also GeoPackage when you are, especially if you are interested in more data in a single request. Then the second topic, GeoPackage with styles. So we are delivering also our topographic map database of Finland as a GeoPackage. It has 112 layers or tables in the database. And then you can visualize or put those on the QGIS and have a different kind of visualization. By default, QGIS is making a random coloring there. So it looks like an art, but it has nothing to do with the actual map. So that's why we decided to create styles also available in GeoPackage. It's using this QML, QGIS markup language, so styles for that. So here is the table structure of the layer styles table in GeoPackage. So this will be read directly by QGIS, and then you have the style information available. You can also put information from styles as SLD, but I'm not sure if QGIS is actually reading that. We have this style QML available, and here I have some style information from our buildings, and the column for style, it's quite extensive, consisting a lot of information there. And here you can see different styling. So two on the left hand side are these random colored things, and the right one on the right hand side, this is the actual styling coming from our layer styles table in our GeoPackage delivering topographic map database. The whole topographic map database GeoPackage for Finland is around 70 gigabytes, and then contours are maybe as a separate GeoPackage, so that's around 10 gigabytes. So I tried to be pretty fast as we were a bit behind of schedule. So back to you, organizers. Thanks.
Jari, thank you very much. Yeah, you managed to actually catch up all the time that we had lost before. So thanks a lot for that. It gives everybody who's here more time for the discussion, which is, I think, also an important part. Alex, is it okay if I hand over the moderation of the discussion back to you?
Of course, no problem, Thorsten. Thanks a lot. So indeed, the floor is open for discussion. If your colleagues want to ask something to any of the presenters or to comment on GeoPackage, please do not hesitate. Raise your hand and then we give you the floor. Or, of course, do not hesitate also to write in the chat. I saw there were some discussions there already, but those were and some questions, but those were already answered by our presenters. So, colleagues, floor is open. Maybe while waiting, I don't see any hands raised for the time being. Just I'll ask a provocative question here, and would like to really hear the feedback of all the presenters, because we start from a conceptual model in Inspire, and we have all the model transformation rules that are encoding independence, and then independent, and then we have also encoding specific rules. But even considering those rules, we can derive different end results. So we can have a different end product. When we have a limited number of examples in several of the inspired data themes, we're absolutely fine. But what is your perspective on how do we deal with mitigating if there are completely, or not completely, but slightly different instantiations and slightly different examples deriving from the same source? So if you have a thought on that, I think this is something that would be useful to discuss and clarify. There is Heidi who wants to elaborate on that. Over to you, Heidi, please.
Yes, that's something that we've been discussing earlier before also in the group. How do we deal with that? We have the conceptual model. That's one model. We can indeed end up with different templates. So I think it was in Torsten's presentation already where we talked about interoperability and the semantic part we have. How about the syntactic part? So you could call it a syntactic interoperability on demand. So at least as I see it, I think we have to work together in different communities. That is what has been done with the noise directive. So that's a community of people who have to deliver those, of organizations that have to deliver and work with those data. So as I see it, you would have to cooperate within a community. The same applies for the addresses. We really want to work with GeoPackage. We have some kind of vision that from our data provider perspective, we want to try to limit the number of formats we make available. There's a lot of proprietary formats that we have been supporting, but it takes a lot of resources. We would prefer to have a standardized approach. So we are very much interested in GeoPackage from that perspective. And of course, we would like to cooperate with other people. So if there's other data providers that have to provide Inspire data, Inspire addresses, then we would be more than happy to receive feedback. We've been working on this 2 people, and we all know that an extra set of eyes or many extra sets of eyes will definitely give, find issues, things that we can improve, and we'll be so happy to hear your feedback. Thank you.
Thanks to you, Heidi. Good question. So it's actually using the opportunity to have a debate in the community and to come up with a consensus agreement that can improve the actual templates so that everyone is happy. I like that answer a lot. Many thanks. I see Kati Schleid wanting the floor, and then Torsten. Kati, over to you.
I was sorry about the background noise. Thank you for the wonderful presentation. My question is on validation of GeoPackage. And I mean, I understand it as an alternative encoding, and therefore the data owner needs to prove compliance. Stefania showed the round trip of then actually taking the GeoPackage, converting that to GML. Will that be available for these, let's say, semi-standardized alternative encodings, or does still each data provider need to prove this on their own?
Yeah, maybe I can respond to that.
Please, Torsten, go ahead, and I can say something as well. Go ahead.
I mean, it's clearly intended that you use a standardized process. So the person who initially, or the organization who initially develops and submits the particular schema should also provide the proof that it can be transformed to the default encoding for validation. But then everybody else can basically reference the good practice as soon as it's been through the process.
Okay, so pertaining to any reporting, basically anybody who provides their data sets with this encoding can then utilize a pre-configured package to reconvert that to GML and validate their data.
Exactly.
Okay, perfect.
No, indeed. Look, here on that topic, we've been discussing with the MIG-T on several occasions already. In the ideal situation, the reference validator would support all the encodings, but clearly this is not feasible given the resources and how difficult it is to create already for the default encoding. So yeah, in the end, the only thing that makes sense from a practical point of view is to do this, to translate between those different encodings and keep it pragmatic that way. Torsten, I think you wanted to react on the previous
Yes.
item. For some reason, I don't see your video. I don't know whether it is me only or all of you.
No, I think I forgot to switch it on again.
Okay, now I see. Yes.
Okay, yeah, on the question of how do you, well, it's obvious that if we do not make like one required mandatory schema per Inspire theme, then there will be overlap and there will potentially be quite a lot, so especially if we think of all these, let's say, different use cases that already mix and match concepts from different Inspire themes, then this is likely going to continue to happen. And so in this case, so we will see some mismatches in between these. So I think that's clear. And we will, as a community, will have kind of to fight this, this not invented here syndrome to some degree. So everybody will kind of go, yeah, I'll do it like this. So I would really like to encourage that you basically, when you create one of these schemas, you say, okay, I did look, are there already schemas that I can use for GeoPackage? I did look at them. I was able to use these things, but I wasn't able to use these and these things. So everybody should potentially make that part of their documentation when there is already something. So because actually, when you remember, for example, the work on the extensions, there was also a lot that we did find already, and there was also overlaps and different people solving the same problems. And we are restarting this. I would encourage that you look at things that you can reuse. Instead of everybody going basically their own path.
Indeed, good recommendations also that are confirmed from lots of practice in harmonization. Stefania.
Yes, just wanted to add my 2 cents there. Clearly, recommendation to always go to this the GitHub or documentation of what's already available. And one push should be that we also provide for the GeoPackage templates already an executable transformation into GMLs. So if they reuse the same template, they can reuse the same executable project to derive a GML or a sample GML and validate with the ETF, so they do not have to do the effort of recreating this executable project. So, and maybe if I can add something that I forgot to mention during my presentation, there is an interesting feature in QGIS. I think most of you are already aware, but you can save the QGIS styles and the project itself in the GeoPackage. So in your GeoPackage, so when you upload in QGIS and you say open from GeoPackage, you will find your data and the styles you have saved there, the relations, the views, and so on, directly saved from QGIS. So something I forgot to mention during my presentation.
Another powerful feature, one of many, right? So that's very interesting, and it will probably only create a few tables. There are one table that will hold that style. Super. Then, no, Stefania, on the executable, definitely, yeah, that makes a lot of sense, as also Torsten mentioned in his presentation. And we actually saw that there are different ways of doing that. So different tools can be used in order to do that, which is also excellent. Let me see if there are other questions. Don't see any. So if you allow me to also put something else on the table. I heard clearly Stefania when she said there are no disadvantages of using GeoPackage. This is actually quite a powerful statement, and it's not always the case with technology. And when I heard that, I started thinking myself, where are the disadvantages actually? And I didn't come up with any. It's fast, it's efficient, it's well supported by clients, it's easy to implement, as our Dutch colleagues mentioned. on the noise reporting. So if you can elaborate a little bit, you're the experts in the group, on what are the possible disadvantages here, and what one should be really careful about when implementing GeoPackage. Please do that, share that with the group. And I see now Thorsten has the hand raised.
Yeah, I mean, I kind of agree with the use of GeoPackage in a GIS to transfer larger data sets. So for that, I also must say I don't really see a disadvantage. I mean, you can always, especially to some proprietary formats like file geodatabase, you will find that there are things where there's no feature parity. Like let's say you're trying to store texture 3D models or things like that. Then you will find that especially the tooling support for GeoPackage in that place as well. But generally, for like 99% of typical GIS data sets that you want to transfer as a whole and want to use in a GIS, for me, there's no reason not to use GeoPackage, to say it very clearly. For other use cases, like for example, we've actually seen the case where GeoPackage is delivered via an API. One should be aware that there's potentially much more effective ways of doing that. So GeoPackage has quite a bit of overhead. So the minimum request size goes up by a factor of about 80 if you compare to GeoJSON, for example, like one small GeoJSON feature compared to a minimal GeoPackage, and so on. So it's not necessarily optimal for everything. But for me, clearly, for enabling GIS people to use in different types of platforms such data sets, I agree with the statement with some like 1% caveats.
Indeed, super. No silver bullet to the encoding question, right? Each of those has a benefit. GeoJSON Web, GeoPackage, GIS, GML with all the validation with the schema. So they all have a good and a bad side, or a good and a bad use case. And I see also Heidi. Please tell us what you think.
Yes, it's not really a disadvantage, but something you have to be aware of, that a GeoPackage, it's a database, it's an SQLite database. So one thing you have to make sure is that if you have large data sets, like our addresses have 2.5 million records, as Lars said, they display really fine in QGIS. But so far, we haven't been paying a lot of attention to other indexes. So we have the spatial index, but we don't have currently an index on other columns. So if you query on one feature with a specific Inspire ID, it actually takes a long time. So when you provide data as GeoPackage, especially when having large files, you have to think carefully about your users will use it, just as you do if you have your internal databases and people are using those. So you need those skills, or you need the database skills of your colleagues in that regards.
Indeed, thanks, Heidi. But I'm wondering what would happen if you try to visualize GML with your 2.5 million records in a desktop application. I think that wouldn't probably be possible at all. So it's quite something actually already. And no, good recommendation from the practice. I see now there is a comment from Pavel in the chat on styling. If you want to elaborate on that one, Pavel, please go ahead now.
Just a moment. Hello, everybody.
Hello, we can hear you.
If I understand correct, that Stefania says that the benefit of the GeoPackage, using the GeoPackage in QGIS, is a connection with style, yes? But you know that from me, the separate style from data, this is the main, yeah? The main idea of the data on the web. The style isn't more important. The Inspire and the sharing of the data should be sharing the data, not that style. Style, the user of data could be add own style to the data which he wanted to present of this data. Yeah? This is in my understanding.
Indeed, thanks for elaborating.
I know that it's a very useful for the end client, of course, but it shouldn't be the main priority of the GeoPackage in the web, in the Inspire in the web.
Clearly, no, as an exchange format, I think the main thing would be to exchange smoothly the data and to be able to leverage on all the benefits with the huge volumes, with the ability to edit. And I think style is one of those possible advantages.
Yes, but
where you share, there is a table, so when you move somewhere, the style is retained. But it's probably, as you're correctly pointing out,
yes,
not
but
the
in my
most
opinion,
important
the same
feature.
situation is with the adding of data. You know, because we share the institution, the public organization, share with data to the other system, not to direct download the data and adding the data in the QGIS in the same format as the data was uploaded.
Clearly so, but if you can edit it, that doesn't hurt, I think.
Yes, yes,
or
of course,
you
of
can
course,
scale it.
of course, but it shouldn't be the priority, of course, yeah? In the same
Clearly.
GML, I know that GML is a very difficult format, but it is the format to exchange data, not the use a direct data in the QGIS or other GIS software.
Indeed so. Let's hear what Stefania has to say.
Yes, just to reply, clearly I was mentioning the possibility to save the styles in case you want to. You are not obliged because, yeah, it is not foreseen, but it is an option that can be useful when you exchange data and you create, when you have, for example, a multi-country data set. So I'm referring to our experience with the GovDev project, where we have Italy, Austria, and other countries. So it is easier and better impact also if you have created views and have categorized those views. But this is something that goes in addition. It's not a requirement. Indeed, yes, cannot be a requirement. And this is not what I meant. Just to clarify there.
Thanks a lot for that clarification. Yes.
Just one other little sentence. What can be done clearly, if we are talking about machine to machine, clearly it is a database, so you can always export an SQL. It's like kind of a dump of your database and provide structures and data. And but it is an option clearly, and another way to share your data.
Indeed so. Thanks, Stefania. Okay. Pavel wants a quick reaction, please.
One comment, please. I agree with Stefania that the styling of direct adding data in a QGIS software is very useful, and it shouldn't be a obligation, could be option. But I don't agree with the dump of SQL database is the data for the sharing between the machine to machine, system to system. In my understanding of Inspire, the idea is establish the common model for the different data and for the sharing this data. Of course, the implementation, for example, Inspire dataset like addresses in different database could be different. And we back in the furious, if we start to sharing SQL databases between systems, we go back in 4 years ago, yeah.
No, you're right. I understand what you're saying, and yes, it was just to reply that in some cases, when clearly we are talking about using GeoPackages, so SQLite database, and so that specific SQL. But clearly, yes, you are right. We are talking about using GeoPackage encoding, which is an alternative encoding specifically meant for use in GIS environment. So this must be said, because this is the first line in our proposal for a good practice for GeoPackage encoding. So clearly that there is no one size fits all, no silver bullets. I mean, yes, you are right.
Agreement, this is good. I see also an interesting comment from Christine, Austria. Hello, Christine. On the Austrian context, where the noise, there is a national legal requirement for the visualization, for the styling of that, which I think is a very specific and interesting use case. Thank you, Christine, for sharing. Okay. No other questions. The clock is ticking. Interesting discussions. 3:26 already. So I suppose we start wrapping it up. And we can do that by very quickly mentioning the several next steps. Let me share with you first the next steps from the JRC on GeoPackage, and then I would kindly ask the colleagues from the working group, the co-organizers of the workshop, to mention the next steps from a community point of view. So this webinar concludes one of the mandatory steps for good practice to be recognized. We have already the initiation, we have all the evidence on GitHub for the different examples that were presented. There is the technical documentation as well. So as was mentioned already, we have a meeting with the MIG and MIG-T in the end of November in Brussels. As part of the agenda, we will be discussing all the good practices, including GeoPackage. There will be an endorsement procedure, and then hopefully, if GeoPackage is endorsed, we will go to the very last step, which is this legal check with our legal service, with DG Environment, in order to once again be 100% sure that nothing from the technical provisions go against the requirements and the legal act. It would be something done internally by the Commission. So this is what we will do after this webinar. And now with that, I would like to hand the floor back to the colleagues to say a few words about how they see the next steps for making sure that all the work that is done is sustainable and can scale to the other data teams and to have a wide uptake by the community.
All right, yeah, maybe just a couple of words. We have 1 minute left. Yeah, I think from my perspective, what's most important is that yeah, I would like to really get all of your input, both more or less your experiences with implementing schemas for alternative encoding and with the technology around that. Anything that you can provide us would be helpful. Also, so if you have other implementation cases, that would be interesting. And then on the other hand, what lies with us is to really document the lessons learned that we have so far in how to build workable solutions for alternative encodings, and basically provide a guide similar to the aforementioned Inspire extensions guide. I think that we'll have one. The parts are there. What needs to be done now is basically final editing and putting everything together.
Excellent. Thank you, Thorsten. And I can only echo what you mentioned. All are encouraged to contribute. GitHub is where all the discussions are already taking place. So please, colleagues, do that. I don't see any other hands raised. So once again, many thanks to all the presenters. Fascinating. I think we were 109 at a certain moment, so lots of interest. You will hear from us with news on how the endorsement process goes, and you can already start keeping fingers crossed that we have, towards the end of November, a fully recognized and endorsed GeoPackage as an Inspire encoding. With that, I think we can close. Presentations are online already. The video recording will be made available, and stay tuned.
Goodbye, everybody. Thanks a lot for your interest.
Thank you. Bye.
Thank you.
Thank you. Bye.
Bye-bye.
Bye-bye.